Hey there, class. Mr. Prosky here. Hope you're having a good day so far. We're continuing with chapter 4, which is about triangles mostly. This one is 4.3. The name of the lesson is Prove Triangles Congruent by Side, Side, Side is what the 3 S's stand for. Our central question is, how do we use side lengths to prove triangles are congruent? Okay, so we have more proofs now, and I know that might, produce a groan, or you might be a little bit worried, but I'm going to give you a proof structure that hopefully will help you kind of keep things straight, and as long as you follow it, you should be in good shape. So let's see how we do. All right, we have a warm-up here. It says, write a congruent statement for the following figures. So you are like matching angles and sides together, so you should have something like triangle ABC is congruent to triangle DEF, something like that, okay? So why don't you guys go ahead and see if you can do that. All right, sounds good. So I like to start with the most unique angle in this in these triangles here, and for me, angle C is the most unique angle because that's an obtuse angle. So I'm going to start with triangle C, and then I'm going to go to, it looks like this one right here is going to be the next smallest angle, so I'm going to do C, B, and then the last one is going to be 3 arcs, which is D, is congruent to, and now we got to do the matching thing on the other diagram. So we have, which angle is the obtuse angle in the other triangle? Well, we have S, so triangle S, and then what's the next smallest angle? It's going to be T, so then we have, angle T, and then we have R as the smallest angle. STR. So this would be a congruent statement. And basically when you do a congruent statement, the reason for that is you can match angle C matches with angle S. Side length BD matches with side length TR. So I would say congruent statements are really helpful to figure out which angles and sides match. So that's why I really like to encourage those. Okay? All right, so we have a postulate, the side, side, side congruence postulate. If basically it says if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are going to be congruent, okay? So let's use some different colors here. So we have AB is congruent to which side in the other triangle? SR over here, okay? Actually, it's going to be RS. If you go AB, it's got to be RS to go the same direction, okay? Let's use a different color. How about BC right here matches with which one in the other one? It's going to be ST. And then we have CA, 3 tick marks there, matches with, is it RT or TR? It's going to be TR because you have to go the same direction. We go C to A, we have to go T to R, same way, okay? And then the congruent statement, ABC is going to be congruent to triangle RST, okay? So, so basically if you have pairs of matching side lengths, all 3 sides of pairs of matching sides all are congruent, then you're going to have congruent triangles, okay? And basically that kind of makes sense, right? If you have all the side lengths are the same, then literally it can't be any different. They have to be congruent, right? Okay, so we have a proof structure down here. So I'm going to write that right down below here, so hopefully you have some room. Here is the proof structure for triangles, okay? We'll write triangle proof structure, actually, okay? All right, step 1, what we start with proofs, no matter what. Same thing here, it's going to be our givens. Okay, step 1 is givens. Step 2, kind of the same thing. We're going to do definition of midpoint or angle bisector. Okay, definition of midpoint or angle bisector. Step 3 is going to be reflexive sides or vertical angles. Reflexive sides or vertical angles. I'm going to put down here shared side, okay? Reflexive or shared sides, okay? And we know what vertical angles are. Step 4 is going to be like side, side, side. We have also another one we're going to have is side, angle, side. Stuff like this, we're going to put etc. That is going to be the 4th step. And then if needed, we're going to do what's called CPCTC, which we'll talk about later. It stands for corresponding parts of congruent triangles are congruent. And basically what that's going to be, we're not going to cover that until 4.6, but basically What it means is if you can prove the triangles are congruent using side, side, side or something, then you can also prove that all the corresponding parts of those triangles are also congruent. Okay? All right, let's do a proof. So use a side, side, side congruence postulate. We have Fj is congruent to Hj, so let's mark that there. We have this. And we know that G is the midpoint of Fh, and we're trying to prove this. All right, so for our proofs, we need statements, and we need a reason. Okay, so let's start with that. Okay, so what do we always start with our proofs? We start with our givens. What are our givens? We know Fj is congruent to Hj, and we know that G is the midpoint of Fh. The reason for that is givens. Okay? All right. What comes next in our proof structure here? Well, it's definition of midpoint and angle bisector. Do we have a midpoint and angle bisector here? We do. So what does that mean? If G is the midpoint of Fh, what does that mean? Well, it means that Fg is congruent to Hg, right? We got to go in that order because the triangles are kind of mirrors of each other. So Fg is congruent to Hg. And the reason for that is definition of midpoint. The definition of the midpoint tells us that we can assume that. All right. Now, are there any vertical angles or reflexive sides? Any shared sides here? We're trying to prove that all three sides are congruent. Where's the third side? Well, the third side is right in the middle here. Now, are those vertical angles or is that a shared side between the two triangles? That is a shared side. So we're going to say for step 3 that JG is congruent to oops, that was bad, JG. And the reason for that is its reflexive property. Reflexive. It's a shared side. A shared side that's obviously going to be congruent to itself. All right, what comes after that? Then comes our little acronym, the side, side, side stuff. So we have all three sides are congruent. We have 1, 2, and 3. We have all three sides congruent. So we can say for step 4 that triangle FGJ is congruent to triangle. So we went FGJ, we got to go the same direction. We're going to go HGJ. The reason for that is side, side, side. And there's our proof. All right? Kind of tricky. Feel free to rewatch this again if it was kind of hard to follow, but I try to make it as simple as possible, and this proof structure up here is pretty important to help us get through these, okay? All right, let's move on to checkpoints here. Okay, it says decide whether the congruent statement is true. Explain your reasoning. So why don't you guys pause the video, see how you do on this, see how you do. All right, so let's see here. Let's look at checkpoint 1. It says JKL is congruent to MKL. Well, the order is correct. It goes this way and this way, which makes sense because they're kind of mirrored. Do we have three sides are congruent? Well, we have 9 and 9. We have 8 and 8. And then we have a shared side. So this is going to be true. And the reason why is side, 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 because we have a reflexive side. We have a shared side, basically. Okay? Number 2, RST. So RST is congruent to TVW. TVW. Well, look at this. RS is this side right here, and then it goes to 2, and then it goes to, so RST. So for this one goes from no side to 2, then it goes to 3. So it looks like it goes in the right order, but do we have a shared side or vertical angles here? We don't. So we can't assume that RS is congruent to TV because there's nothing here like a shared side that would actually prove that. So no, we can't. If we could assume that those were going to be congruent using reflexive or whatever, we can't assume the third side is congruent. Okay? Got 2 out of 3, but we need all 3 sides to be matching for side, side, side. Okay. Now we got some more examples here. Write a congruent statement for the following figures by matching the corresponding parts of the triangles. Okay. Well, let's go ahead and do this. Actually, why don't you guys go ahead and do this? See if you can pick an angle and then try to go pick an angle and go around the triangle and try to keep write a congruent statement. Which triangles are congruent based on the angles, okay? Give it a try, see how you do. All right, with number 3, I like to go from 1 arc to 2 arcs to 3 arcs. So I'm going to go from here to here to here. So for example, I can say triangle LJK, which goes from 1 to 2 to 3 arcs. And then I got to do the same thing in the other one. It's going to be the same thing as 1, 2, 3, which is going to be LTU. Okay, and there's other variations of this you can do. You could actually do like, KJL. You could do any kind of variation. As long as you're consistent and you match the angles correctly, your congruent statement will work. But this is what I did for this one here, okay? Number 4, let's do a similar thing. I like to do 1 arc, 2 arcs, 3 arcs. So I'm going to do the same thing. So I'm going to do 1 is L, 2 is J, 3 is K. It's congruent to triangle. And then we have 1 is X, 2 is K, and 3 is V. So we have XKV. And that's my congruent statement. And like I said, if you do a congruent statement correctly, you can match up angles and sides. So JK matches with KV, right? So you can see that JK is 2 and KV is also 2, right? So if you do it correctly, it should match up the sides very nicely, which is why these are useful. All right, last thing, we're trying to determine which side or angle is corresponding to the other figure. All right, so we're matching. Why don't you guys see if you can do this one? Give it a try. All right, so we're looking, we have IJK and IFG. So we're matching angle J, which is the middle letter of this congruent statement. Which one matches with angle J? It's going to be angle F. So we can say over here would be angle F would be the corresponding figure, okay? Corresponding angle. Over here, WU, we have a WUV is congruent to UWG. So we have WU is going to match with what? It's going to be UW. It's kind of weird, but that's a shared side, so it's going to be kind of backwards, but UW is going to be the shared side. All right, and that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.